Hello, welcome back. This is our second video as we are working our way through chapter 23, and we are covering missed part of my tube. And we are covering the means, a hypothesis test for means and confidence intervals for means. This is going to be a single t-test, not a two-part t-test. So, just as we start off here in the previous video, we did a hypothesis test. In this video, we're going to talk confidence intervals. Before we jump into that, I just want to remind you a quick thing when we talk about this terminology, statistically significant. And to remind you, as we have in previous chapters, that the term statistically significant does not mean important. It does not mean meaningful. What it does mean is that the sample mean we have is not the result of sampling variation. We see this because the p-value of the hypothesis test is below our alpha value. Again, remember, a p-value is a probability. P-value is a probability. And it's the probability that if the null hypothesis were true, that we would see this particular sample mean or one more extreme. And because we had a low p-value, means we had a very low probability of this sample mean being true given the null hypothesis. So statistically significant just means we found a p-value below the alpha value. That is it. There's no other meaning to it. It simply means that we have decided that it is not the result of sampling variation. It is beyond that. It means that our null hypothesis, there's evidence that the null hypothesis is not true. So, with that being said, let's move on and talk a little bit about confidence intervals. So, we used this particular value for finding a t-score when looking at a sample mean. This was our standard error down here. It follows a student's t model, and we have n-1 degrees of freedom. Remember, that's a family of models, of normal models, or normal looking models, I should say, where the variation increases the lower the sample size is. As we increase the sample size, the variation decreases. So, moving this into talking about a confidence interval, that T model that we created corrected the extra uncertainty, that variation that got added, and our margin of error got bigger. Your confidence intervals will be just a bit wider and your p-values just a bit larger than they were with the normal model. By using the T models, we've been compensating for that extra variability so that it doesn't create a problem. Now, what that means is when we go to make our interval, it has the same conditions that have to be met. It has to have a normal, the two conditions being that it has to come from a random sample of data, and it has to be nearly normal. Excuse me. And as long as those two conditions are met, we can create a confidence interval. And this might have different symbols than when we did the proportions, but remember, all confidence intervals are in the same format. It's our sample statistic, plus or minus our margin of error. In this case, our margin of error is defined as our critical t-value, addressing that it's a t model instead of a z model, times our standard error, which in this case again is the sample standard deviation over the square root of n. Finding that critical value, again, this critical value depends on two things now. It depends on the confidence level, so 95%, 90%, whatever, but it also depends on the degrees of freedom which we get from the sample size. So in a future video, we are going to do that bit. We're going to do that bit where we learn how to hand calculate that or calculate that on the calculator. For today, we're going to do the confidence interval simply on our calculator. So let's jump right into that, and let's use the same example that we used for our hypothesis test. We're going to create a 95% confidence interval for the mean amount of coffee being dispensed into the machine. Let's just maybe remind you guys real quick of the particular situation we're looking at here. We had a coffee machine that was dispensing coffee into paper cups. You're supposed to get about 10 ounces of coffee, but the amount varies slightly from cup to cup. So here, this data table below is the 20 cups that they got, and we're looking at, is there evidence that they're shortchanging? So we are going to create a 95% confidence interval for those cups, and it just so happens that, like I said, we're going to do it on our calculators today. I have this information in a list on our calculator. That's our 20 cups of coffee over there in list 1. And we're going to use that information to run the confidence interval. So stat, tests, where all of our statistics tests are. For the hypothesis test, we use this one that was t-test. You'll look around again and you're looking for like the one sample t interval. You won't find it. The one that you need is this one right here that says t interval. So there's t test and then there's t interval, and you hit enter. And just like on the t test, you can choose 2 different ways to do it. You can do the data or you can do the statistics. These are the correct statistics for the coffee piece. These are the data is in list 1, so it does not matter how we do this. So I'm going to just go ahead and scroll down here and calculate, and that is my confidence interval, 9.752 to 9.938. So we're going to put that information down here on our show. 9.752 and 9.938. 9.752 and 9.938. 9.732 to 9.938, if I remember correctly. I hope I got that right. So we calculated the interval. That is the 95% confidence interval there. By the way, we should have our conditions met for this. We did check the conditions when we did the hypothesis test. On the AP exam, if you're asked a hypothesis test and then a confidence interval, it is okay to say, we met the conditions. We met the conditions in a previous problem. Oops. In a previous problem. We will conduct a 1 sample t interval. Now, again, if you were just doing just this without having to already do those conditions, you're going to need to make sure that you meet the randomness and the nearly normal. And when you do the nearly normal, you're going to want to make sure that you have a picture of your histogram, right? Like a picture of histogram to show that it's nearly normal. Again, we proved these conditions were met in a previous video, and so I'm not going to redo them here. Again, you can watch the last part of the video on the hypothesis test with this question if you'd like to see that. So conditions were met. My mechanics created this interval. We could state on here maybe to be a little more thorough what our mean and our standard deviation were, which we have on here. It's 9.8, 9.84 and 0.198, 9.84, 1.98, 9.84, 1.98, 9.84, 0.198. So that's my sample mean and my standard deviation. Sample standard deviation. There's my confidence interval. The last thing we need to do here is write our conclusion. And our conclusion is going to be that we are 95% confident that the coffee, or the mean coffee amount, that says amount. I don't know why it got all messed up. Amount is between 9.732 and 9.938 ounces. Again, the three important parts when you're writing your interval is to state your confidence, you need to state your context, and finally you need to state the interval. And that's the same as when we did the proportions tests previously. So there's our interval. It kind of creates a list of plausible values for what we might think the mean amount of coffee that's being used from this machine is. Let's just add a couple more words about confidence intervals here, and then we'll be done with this particular video. So remember to interpret your confidence interval correctly. Okay, these are all examples of things not to say. So 90% of all of the vehicles on Trip Hammer Road drive at a speed between 29.5 and 32.5 miles per hour, right? That is the wrong thing to say. It is not correctly interpreting your interval, because the interval is about the mean, not the individual values, right? We need to be talking about the mean speed of the vehicles on Trip Hammer Road, okay? Another thing not to say, we are 90% confident that a randomly selected vehicle will have a speed between 29.5 and 32.5. Again, this is wrong because it's about the mean. The confidence interval doesn't tell us anything about if we were to randomly select somebody what the range is going to be within. That's not correct at all, right? We might get something really far outside of this because maybe somebody's going like 40 miles an hour. It's not a 90% chance that we'll get somebody within that interval. The confidence interval is telling us about the mean, not the individual values. Other things not to say. The mean speed of vehicles is 31.0 miles per hour 90% of the time. You could also say the mean speed is within 29.5 to 32.5 90% of the time. That is a wrong thing to say, right? The true mean does not vary. The true mean is a set thing, right? It's the confidence interval that would be different had we gotten a different sample. So every sample that we create is going to create a different confidence interval, and it's not telling us exactly what the mean is this amount of the time. That's different. Okay. And then the last one of the wrong things to say, 90% of all samples will have mean speeds between 29.5 and 32.5. Now, this one I warn you because it is the most correct sounding one, but it is not correct. Because the interval that we have calculated does not set a standard for every other interval, right? This interval that was calculated in a problem does not tell us that 90% of all samples are going to have intervals like that, or that the mean speeds will be between those, right? It's no more or less likely to be correct than any other interval. Again, every sample is going to create a different interval, and it doesn't tell us anything about what the mean speeds are going to be. It doesn't push it in there. The correct interpretation is 90% of intervals that could be found in this way would cover the true value, right? That's the very general way of saying it. 90% of intervals that could be found with this sample size would cover the true value. Or, if you want to make it more personal and give it that context, you would say, I am 90% confident that the true mean is between 29.5 and 32.5 miles per hour. Again, just to draw this picture, and then we'll end it right here. If we've got a graph here, and this line right here is the true mean, every time I calculate a different confidence interval, I'm going to get a different, or every time I use a different sample, I'm going to get a different confidence interval. And some of those confidence intervals are going to capture the true mean, and we will know it. Others are going to miss that true mean. Again, we won't know it if it misses the true mean. So some of these are going to work, and some of them are not going to work. The whole point of confidence is that 90% of the intervals, 90% of the intervals will capture the true mean, right? If I were to take 100 samples, 90 of those samples are going to create an interval that has this true mean in it. That's what confidence is. To say that I'm 90% confident tells me that if I were to make 100 samples, that I would expect 90 of them to contain the true mean. That's where we're going to end it today. We're going to do one more video in this series on chapter 23. It's going to cover hand finding a t-value, a critical t-value for a confidence interval, and it's also going to have a couple more just problems to be done. Okay? So, thank you very much for watching. Again, like always, if you have questions, leave them in the comments or find a way to contact me, and I will make sure I get those things answered for you. Thank you very much.